Welcome to TechVerse. In this video I'll be showing you how you can make a power supply. It's a switch mount power supply with any desired output voltage found directly from the mains. The power supply is based on the UC3843 switch mount power supply IC. So all the component values and the connections are shown. So let's go through the working. And the input you have your mains. There's a fuse and an NTC thermistor for limiting the inrush current. There is also a filter made up of this capacitor, this common mode choke inductor, and this capacitor. So this eliminates the high frequencies from the power supply from interfering with the low frequency mains. So there is also some high voltage capacitors which establish a ground potential in between them. So then it's followed by a full bridge rectifier. So here you have your pulsating DC, which is filtered by this bulk capacitor. So there's a distance resistor which distances the bulk capacitor when the power supply is disconnected from the mains. So the IC receives its power directly from the mains through this diode and this high wattage resistor. So then this is pin 7, the voltage is kept steady at about 18 volts by this Zener diode, and there's a small storage capacitor for keeping the voltage steady at the input VCC pin of the IC. So all the other connections are shown. Connect pin 2 and 5 to ground on the negative rail, connect pin 3 to the negative rail through a derivative equivalent capacitor. All the other connections are shown. So this is the frequency determining resistor as well as the 4.7 nanofarads capacitor. All the connections are shown. So the output pin 6 goes to the gate of the MOSFET through this 22 ohms resistor. There is also a gate voltage limiting Zener diode of 18 volts to protect the MOSFET from overvoltage across its gate and source. There is also a current sensing resistor which is 0.56 ohms. So this limits the maximum current drawn by the MOSFET on the primary side, which also acts as a power limiting resistor. You can change the values of the resistor for any desired amounts of current on the primary side. So the MOSFET is the IRF 840, but if you want more power, you can use the IRF 460 or 450, since they can handle up to about 20 amperes. Just ensure that they are rated at least more than 500 volts. You can also use the 20N60 MOSFET. So the primary turns are shown. The turns ratio between the primary and secondary is 4:1. So on the primary side you can have 90 turns, and on the secondary side you can have about 22 turns. So when the MOSFET is turned on by a high signal from the pin 6, so current will flow through the primary winding into ground. So when the MOSFET turns on, all the energy stored in the core will be transferred to the secondary side, where it is rectified by this high frequency diode and filtered by these two bulk capacitors. There is also a small minimum load resistor on the secondary side to ensure that the output remains steady. So there is also voltage regulation achieved by the precision reference IC TL431. So there is a resistor dependent network. So when 2.5 volts develop across this node, the TL431 will begin conduction, and this will allow current to flow from the positive output on the secondary side through this resistor, through this LED. So this LED will indicate when there is voltage regulation. Also through the internal infrared LED of the optocopper, through the TL431 IC, and to the negative rail on the output side. So when this happens, so it will shut the feedback pin 1 of the IC to ground, and so this will limit the duty cycle at pin 6 to keep the output at the desired output voltage. So the output voltage is directly proportional to the secondary windings. So for the optocopper you can use the PC817. It's very common and reliable. It can handle up to 80 volts and a current of about 50 milliamps. So that's all about this switch mount power supply. Or also, I forget there's a small snubber network made up by this high frequency switching diode, the UF4007, and this capacitor. So what happens is when the MOSFET switches off, Any voltage spikes generated will be shortened across the primary winding through this high frequency diode, so the capacitor will charge and then it will be discharged by this resistor. So ensure that the capacitor is large enough to handle the heat generated when it is being charged and discharged. So don't forget to drop a like and subscribe for more amazing tutorials and projects, and hit the notifications bell for updates about future uploads. Have a nice time.